Hello, welcome to Bowling Tech News. My name is James, and we'll be talking about everything bowling on this channel. I've been all over social media. I'm on several forums, and one of the most asked topics I see on there is concerning bowling balls and cracking and how to prevent that from happening. I'm asked this question at many tournaments. I'm asked this question during league play. Many people get new balls, and within a few days they're cracked, and they don't know why. There are several methods people try to prevent the bowling balls from cracking. Some work, some don't work, some used to work, and some are just plain out myths. And today I will explain what works, and I will tell you why they actually work. So stay tuned. The first thing when you're talking about bowling ball cracking and cover stocks cracking is you need to talk about ambient temperatures. Most resins have a really wide range that they operate in. They're extremely durable in those temperature ranges. However, each type of resin expands and contracts at different rates. Your denser resins, like those that are found in the bowling ball cores, expand much faster or contract much faster because they're dense. And they're often made out of slightly different materials. Your outer core, which are also known as your filler, that's the part that goes around the core itself, also expands and contracts because it can be denser or lighter than the core and the cover stock. The outer core material also usually expands faster, expands and contracts faster than the cover stock itself. This expansion and contraction puts a lot of pressure on this cover stock. These cover stocks are not very thick. They're usually somewhere between a ½ inch to an inch thick. Some go a little thinner, some go a little thicker. There's very different depending on the type of ball and the type of reaction they're trying to get, then the type of cover stock and the structural integrity that it needs. And these materials vary from bowling ball manufacturer to bowling ball manufacturer, and even from bowling ball to bowling ball, and in some cases even from different bowling balls weights within the same bowling ball itself. So you need to know that expansion contraction puts a lot of pressure on this. So you want to keep them at a constant temperature if possible. Slight variations in the temperature, 2, 3, 4, 5 degrees is not going to be a big deal. It's when you start talking about those higher temperature differentials that can cause a lot of stress to be placed on the bowling ball. One misconception is that only heat can cause a bowling ball cover to crack. That is not true. That's a myth. There are different layers to a bowling ball, and they're chemically and they are mechanically bonded to one another, so that chemical and mechanical bond can actually cause pressure to actually build a little faster. If they were loosely done, then one could expand a little bit and not bother the other. But because they're mechanically and chemically bonded by how the process is done for making bowling balls, they can crack if the temperature differential gets too high. This means that both contraction and expansion puts pressure on the cover stock material. So one method is try to keep balls away from extreme temperature swings. We're talking about temperature swings of like going outside during the winter, like it is right now, and get it, and it being 30 degrees Fahrenheit, and bring it into a room temperature of 60 to 70 degrees Fahrenheit. All of a sudden, there is a huge amount of temperature differential on the outer cover stock, because the outer cover stock is going to actually, the cover stock is actually going to heat up faster than the inner core, which means that it's going to expand, and then because it's chemically bonded and mechanically bonded, what's going to happen is it's going to be pulling it's going to be pulling on that inner cover, on that outer cover. The inner cover is going to be pulling on that inner core material, on the outer core material, and literally trying to pull it away. And once it tries to pull that away, it weakens the cover stock, which can cause that to crack over time. Keep bowling balls at uniform temperatures, and what I mean by this is the ball should be at approximately the same temperatures whenever possible. Recently, I read a post of a bowler who was exasperated by another one of his balls who had cracked, and he asked me what could cause this. So let's walk through a few more things outside of ambient temperature that most people will probably not know about or not have really thought through the process of what really happens. One of the largest ones that I see is sunlight. Sunlight can have two different effects. The first effect we're going to talk about is heating the ball non-uniformly. Like any round surface or object, the sun will only hit part of the ball. So if the sun is here and it's shining this way, it's only going to hit this side of the ball, which creates heat on this side of the ball, because light can create heat, and especially on darker balls. Meanwhile, the opposite side doesn't get any direct sunlight, so this side heats up faster, causing pressure, internal pressure and external pressure on the ball, which will, boom, make it crack. And it cracks very quickly from that. Especially if your ambient temperature is, let's say, 67 or 70 degrees Fahrenheit, and there's a lot of sun coming in, and this side right here can be 90 degrees because it's a darker material. The outside right here can be 90 degrees, and this side right here is going to be at ambient temperature for the most part. So what's going to happen is it's going to find the weakest spot, which is where it's been drilled right here, these drill holes, and it's just going to start cracking. It's going to start cracking around them, and then it's going to crack along a fissure around that part where the sun was hitting and where it was cooler. They're just expanding at different rates. So you want to really keep them out of the sun as much as possible. You want to try to keep them away from sunlight, because sunlight is going to impart energy, heat energy into the ball, and that's bad for the ball. Another concern, the second concern that I talked about with sunlight, is UV degradation of resins. All resins and plastics, when sunlight hits them and UV rays hit them, it's very dangerous, because it really weakens the polymers inside of these resins. UV light breaks down resin materials and makes them much weaker over time. Now, we're not talking about 5-6 minutes out in the sunlight. We're not talking about that kind of exposure. We're talking about exposure over long periods of time. We're talking about days and days and days. It will weaken the ball. So just a weak exposure, a quick exposure. You have to take it out to take it into the pro shop, or you have to take it out to bring it into the house, is not going to bother the ball. But longer exposures can and will weaken the exterior resins. So keep them out of the sun as much as possible. Another thing that people don't generally think about is airflow. Air that is blown out of AC vents is either much colder or warmer, depending on if the heat is on or if the AC is on, than your room ambient temperature. And that's because you're dealing with a hole about half the size of this piece of paper, something like this, right here, having to cool an entire room or heat an entire room. That's just how HVAC systems work. After all, these few small holes are blowing large volumes of air, and that air has to be either warmer or cooler to heat or cool that room. By placing a ball near one of these vents, you can cause both expansion and contraction, and a difference in temperature on one side of the ball. So if the air is blowing from right here and is blowing up onto this ball, it's going to heat or cool this side of the ball and not on the back side of the ball where the vent is not blowing. And that difference of temperature, just like the sunlight difference of temperature, will crack the ball. So you don't want to place this anywhere near an AC, an HVAC system vent, whether it be exhaust or intake. I always tell people to try to keep them somewhere, several feet away, just so that no direct airflow gets onto them. You want to have the least amount of turbulent air around these things, because that can cause temperature differentiation. So keep them out of direct airflow. The third thing that we talk about really is dissimilar materials. Things like wood, metal, non-similar plastics and polymers can cause a ball to crack. And it's because they transfer heat at different rates. They're different materials. Woods can actually do something to a ball that is very bad for a ball. These balls have resin, they have plasticizers, they have liquids literally suspended inside of these that keep this ball pliable. It keeps this ball a little flexible, so that when it hits a pin, it doesn't actually become brittle and crack. These are these balls have those materials, those plasticizers in them. And by placing them on wood has a tendency to want to soak up plasticizers. Plasticizers are usually kind of petroleum type materials, and try put any kind of oil on a wood and it's just going to soak it into the wood. So you don't want to put it directly on there for any length of time. Once again, short periods of time is not a big deal. A few minutes here or there is not going to bother the materials inside of here, because it's just not going to have time enough to leach out and into the wood. So you don't really want to place it on wood, because they can actually absorb those chemicals that provide the elasticity for cover stocks, making them easier to crack. Other materials like metal can cause temperature differences due to thermal transfer rates. Metals tend to don't tend, they almost all transfer heat and much faster than a ball can, than a resin. Resins are a little bit slower, and that can cause wherever the metal is touching the ball, that can cause that ball, that area to actually be hotter or colder. Once again, like we've talked before, and causes those areas to be weakened, because those areas are at a very different temperature and can cause cover stocks to become weak in those areas and crack over time. So you don't want to do that. Me personally, I've seen people use these. I don't use these for long-term storage. I can use these for short-term things, like if I'm at the lanes and I just want to set it down for a few seconds and need something stable to place it on. I'll go and use this and carry it with me. It's very small, very lightweight, but I don't use these for long-term storage, and they're not recommended for long-term storage because of this, because of the flat part right here. The flat part is actually going to be touching a material that is not like this ball. Therefore, this thin plastic will actually cause the heat to transfer a little faster than you really want, and can cause weakening of the ball and will eventually crack the ball. Me personally, I use this 3-inch Schedule 40 PVC. This is a coupling that I use, and it has what's known as a chamfered edge. These chamfered edges are really great for bowling balls, in that it applies the pressure evenly, because the ball sits down into the chamfered edge. And the PVC, the Schedule 40 PVC are very similar to the plasticizers in this, and these are chemically resistant, meaning that they will not soak up or try to draw out like wood would the chemicals inside of the ball, the plasticizers inside of the ball. They just don't want to do that. So they're chemically resistant, and they work very well. And So I'll place some links below to where I buy mine, and there are several different areas. There's several different places that you can buy them. They're not very expensive. They're just a few dollars, $3-4. Another advantage of these is that look at the height differential here. This is very, very high. This is several inches high, and it's going to keep it away from dissimilar materials that will transfer heat. Now, what I do occasionally do, if I'm going to have a ball that I'm not, where I know I'm not going to use it for several weeks or several months, I have others that I have little holes. Throughout the sides. I usually put one or two, usually two, for pass-through air, so that the temperature differential inside of this chamber that's created by these surfaces meeting, that the temperature inside can all be the same. So you always end up with the same temperature all the way around, or very similar temperatures within a couple of degrees. I'll place some links below on that, and we'll talk about that a little later. Schedule 40 PVC is chemically stable material, and as long as it's not exposed to direct sunlight. But as we talked about earlier, you don't want to expose your ball to direct sunlight either, because that will cause your ball to crack. It'll weaken the cover stock. So you don't want to do that. So these are really cool to use, really great to use. They keep a good distance between dissimilar materials, and they actually help my ball, and they're very, very stable. They're very stable. It's very difficult to do that, and they won't scratch the ball either, because they're a little softer than the ball, so they won't scratch the ball. The fourth thing that I hear about, and I find out about later on, is that people are using non-approved cleaning solutions. Never use chemicals to clean your equipment that are not specifically approved by USBC and or the PBA for competition before or after use. Modern ball cover stocks are highly advanced resins. These are researched and developed over a long period of time by manufacturers, and they're tested against approved chemicals. These chemicals are pretty much guaranteed to not destroy your ball and or weaken the materials. Prohibited chemicals can make resins and cover stocks even more brittle, or they can make them chemically unstable. You hear a lot about that, where people used to take some chemicals. I'm not going to mention them here because I don't want people trying it. They take some chemicals and can literally put them on there and make them real tacky. Some tack is fine, but they make them really, really tacky. And what you're doing is you're literally making the outer part of this ball chemically unstable. And that is a bad thing, because it will cause it to later weaken up and will cause it to crack. You need to protect your investment by not doing that. There are plenty of cleaners out there that don't hurt your ball. They're made by manufacturers. They're made by third-party manufacturers who don't actually make balls, but make cleaning solutions that are approved by both the USBC and or the PBA to be used. And these chemicals that they use in there are specifically researched, and they are specifically tested to make sure that that you do not destroy your ball and crack your ball in some way or another. And they're legal. That has been that's a benefit of not getting you thrown out of tournaments, or getting your USBC card yanked or your PBA card yanked because you're using unapproved chemicals that make the ball illegal. We'll talk about a lot of these later on. We're going to meet with some manufacturers later on. We're going to talk about those cleaning solutions and chemicals that can be used, and why, and which ones are good for which balls and what kind of reactions. We'll talk about that later on this episode. So stay on this channel. So stay tuned for that. Placing a ball in an oven. Ooh. I've heard about people doing that to get oil out. Oh, just don't do it. Don't do it. There are some pieces of equipment that you can purchase, or your pro shop will most likely have, that they call, quote, baking the ball. Those can work, and those do work, and they can do it safely because they're tested to do so. But placing them in your oven, oh geez, really don't do that. It's not a good idea. It's dangerous not only for the ball, but it can be dangerous for you, because these balls, when they're heated up past a certain temperature, usually around 200, 250 degrees Fahrenheit, they can really cause problems with releasing toxic chemicals into the air, which can cause you problems, your health problems. So just don't do that. These are not the balls of old that you can do that with. Once again, these are highly complex chemical resins that they use in these. They're highly complex. They're very, very, very specifically designed to do certain things at a specific operation temperature. And exceeding that operation temperature to get a little bit of oil out is not a good idea, because you're not only going to do that, but you're also not taking out just oil. You're also taking out the elasticizers, the things that make these things more durable. Well, anyway, we'll talk about that in a later episode, why you don't want to do that, what happens when you do that. We'll talk about that a little later episode. So if you like this video, give us a thumbs up. You know, we always like that. Share it with your friends on social media and forward it on. We love that kind of stuff. Place your comments below and subscribe to this channel for new videos on the sport of bowling. Until next time, hey, keep them rolling.